macromolecular docking, and I'll be using Discovery Studio and Molegro Virtual Docker to do that. Now, why is this very important? Because once you have the dimensions of the active site, it means you are targeting the correct site for docking. And that means that your results are reliable. So this is very important. Remember, like I've told you before, not every part of the protein is the active site. There is an actual site that is called the active site, and it's the interaction in that site that is important. So by knowing that dimension, it helps you to target the correct site you're working with. Secondly, with this dimension, docking is faster. Imagine that you're trying to dock all around your compounds all around the protein. It will be very slow and it will take a lot of time and your memory. So in terms of efficiency, getting the correct dimensions helps you. It makes your work shorter, and then it makes it more reliable. Also, your docking will not be considered to be accurate if you are not working with the dimensions of the active site. It will not be considered to be accurate, because the question is, how do you know if your results are correct, since the protein has a large surface that you can dock with. So with the dimensions of the active site, it gives your result some form of accuracy. The last thing is that with the dimensions of the active site, your result is reproducible. It means that when somebody else use the same dimension and then try to dock his or her compound using that same dimension, that person um, can have reproducible results. In fact, if the person takes your compound and then use the same dimension, the person is supposed to obtain results that are very close to what you obtained. So it's very good for reproducibility to obtain results that are consistent. Now, how do we do this? The first thing to do is to download a protein. So I'll be doing that. Let's download a protein. Now, so we'll go to rcsb.org. Now I have a protein in mind. I told us the last time that the choice of protein you would be using will be dependent on the literature review you've conducted. So I'll be using 1K3A, assuming that we are doing an anti-diabetic related work. So 1K3A, I will download the protein. Please, before you download your protein, you must have done an extensive literature review to know the protein you are working with. So go to PDB. Okay, so we have PDB. Now the next thing I want to show you is this. Let's go down and let's look at some of the things that are in on the page for this macromolecule. Now the first thing we have is macromolecules, and that gives us the protein insulin-like growth factor 1, but that's not what we are really interested in. We are interested in the co-crystallized ligand. So let's go down, look at small molecules. You can see that small molecules, and then there's a ligand there, and there's a unique ligand having what? ACP. That's the identification number. Look at the diagram of that compound, of that ligand. Now this ligand is buried within the cavity of that protein, and it's what we'll be using to find the dimensions of for our docking. So sometimes I often want to download the ligand. So there's a modified residue PTR, but we are not using our. So our focus is ACP. Please mark it. It's important you know that this is ACP, because we'll be using this when we want to obtain our dimensions. So I've downloaded it. Now the next thing you should do is to go to Discovery Studio. So let's open Discovery Studio. New molecule window. Click on it. This is good. Now the next thing we're going to do is to import that protein we downloaded. Remember it's 1K3A, so we should find it in downloads. Okay, so this is it, 1K3A. Wow, so you can see it. Now let's open it up. You can see the different strands. You can see the water that it contains, water molecules, which is shown in red. Observe what happens when I click on the water. See, it disappears, and when I check it, it appears. Now we also have some ligand groups. You can see them. Okay, you can see I've highlighted one and the other. So let me take this one off, and then you can see this. I highlighted this. Now, so we're going to be using ACP. Let's check it. That's ACP. And we're going to be using to obtain the dimension. So let's look for ACP. I think we should find it. Not here. Okay, cool. So you can see that this is ACP. Now it's even highlighted here. Now we can even look at a 2D diagram of ACP. You can see ACP. This is the compound, but that's not what we're interested in. We're just interested in obtaining dimensions. So let's close this. So go to ACP, right click, and then go to attribute of ACP 300. Click on it, and then you see, interestingly, you would find the attributes, the name, the ID, the color, and then when you go down, you find XYZ. Now, XYZ refers to the dimensions of that ligand within the protein, and that's what we are going to be working with. So you can open, what I often do is to open a notepad. Open a notepad. Okay, Control N, and then I can paste it there. So using this is X. Remember, it's XYZ. Don't forget it's X. So X is equals to this, Y, and Z equals to this. So you see, you've obtained the dimensions, and then you can work with a grid box of 25 Armstrongs. That's what we often use, or even lesser. You don't want the grid box to be too large because it means that it will be slow and then your results will not be reliable. So these are the dimensions. X is 25.799238, Y is 14.016245, and Z is 47.332508. So you've seen how you can use Discovery Studio to obtain your dimension. Now let's use, so I can cancel it, and then let's use another software to do the same thing. Let's use Molegro Virtual Docker. Molegro Virtual Docker. So I'll open Molegro, click on Molegro. You must have installed it, and if you don't know how to install it, there are videos that can help you do that. However, if you encounter any challenge, please just get across to me. So let's import. Now, how do you import? Go to downloads, 1K3, the same. Good. And now here we are now importing with water. Now with protein, ligand, but the ligand we're interested in is ACP. So I will not work with, so I will import this. Good. Now if you look at this, this is your protein, and then you have that ligand. You can see it's ACP 300. in Molegro. So let's see how we can obtain the dimensions from Molegro. So go to search page setup. Now, when you click on search page setup, it often goes to the center, but we want ACP. Okay, let's see, center. Okay, 18.68. That's not what we want, but we want ACP. Now, look at ACP. Look at the dimensions. What are they? X is 25.78, Y is 14.00, and Z is 47.34. Let's compare to what we have from Discovery Studio. So in this case, it means that we have X to be equals to 25.78. I think that's quite close. Y is equals to, Y is equals to 14.00, and Z is equals to 47.34. Now you observe that um the dimensions obtained from Molegro Virtual Docker are very close to that of Discovery Studio. Look at it: 25.78, 14.00, and then 47.34. So because they are different softwares, they are different algorithms, they will have slight differences in the or in the dimensions of the coordinates. But it's important you know that this is how you can do it. This is very, very easy. And then you can now look at, for this, for Molegro Virtual Docker, the radius is using is 15 Armstrong. We can make it larger if we want. Wow, we can even make it lesser. You can see that. You can see that. And then, so these are the ways of obtaining our dimensions for the active site. Remember, what did we do? The first thing we did was to download the protein, and then we identified the crystallized ligand, and we used it to obtain the dimensions of the active site. Remember, the crystallized ligand is a ligand that is buried within the protein once you download it. Maybe if you want to use Pyrex or Autodoc Vina, you can easily use these dimensions, plug it into those algorithms, and then you will get a reliable result. I will show you that next time. Thank you for listening.